Hello everyone, we are group S3 and welcome to our video. So in today's video we will be discussing about how to fetch a word from memory and store the word in a memory.
Hello everyone, my name is Rajiv Tapria and I will be talking about register transfers. Instruction execution involves a sequence of steps in which data is transferred from one register to another. For each register, two control signals are used to place the contents of that register on the bus or to load the data on the bus into the register. When Ri, that is R input, is is set to 1, the data on the bus are loaded into Rin, are loaded into the register R. Similarly, when R out is set to 1, the contents of the register are placed on the bus. While R out is equal to 0, the bus can be used for transferring data from other register. Coming to the next part, Tanmay will be explaining an example.
Myself Tanmay, and now I'm going to explain about the example of register transfer. So in the example you can see move R1 R4. The transfer of the content of register R1 to register R4, this can be accomplished as follows. This process takes in following ways, like enable the output of register R1 by setting R1 out to 1. This places the contents of R1 on the processor bus. Now the second step is enable the input of register R4 by setting R4 into 1. This loads data from the processor bus into register R4. The third step is all operations and data transfers within the processor takes place within the time period defined by the processor clock. And the last step, the control signal that govern a particular transfer are adjusted at the start of the clock cycle.
So, hello guys, my name is Shubham Taide, and now let's get on to the next topic, that is fetching a word from memory. The processor has to specify the address of the memory location where this information is stored and request a read operation. This applies whether the information to be fetched represents an instruction in a program or an operand specified by an instruction. The processor transfers the required address to the MAR, whose output is connected to the address lines of the memory bus. So here we have a diagram that is connection and control signals MDR. At the same time, the processor uses the control lines of the memory bus to indicate that a read operation is needed. When the requested data are received from the memory, they are stored in register MDR, from where they can be transferred to other registers in the processor. The response time of each memory access varies, that is cache, like cache, memory mapped IO, etc. To accommodate this, the processor waits until it receives an indication that a requested operation has been completed. Mapped function completed, MFC.
So now let's move on to the examples of fetching a word from a memory. So first we'll take an example of how to move R1 to R2. So the output of MAR is enabled all the time. Thus the contents of MAR are always visible on the address line of the memory bus. When a new address is loaded into MAR, it will appear on the memory bus at the beginning of the next clock cycle. A read control signal is activated at the same time MAR is loaded. This means memory read operations requires 3 steps which can be described by the signals being activated as follows. So first one is R1 out, MAR in and read, MDR in, E, WMFC, and the third step is MDR out, R2 in.
Hello everyone, I am Shreya. So, storing a word in a memory, writing a word into a memory location follows a similar procedure. The desired address is loaded into MAR, then the data to be written are loaded into MDR, and a write command is issued.
Hello, myself Pranav Tade and I am here to explain you the examples. So, example, move R2, R1 requires the following steps. R1 out, MAR in, R2 out, MDR in, write, MDR out E, WMFC. Thank you.